Game should be live. Testing the sound. Okay, I'm sharing the wrong screen. Sharing the wrong screen. Okay, this should be better. It's the screen we're sharing. It's the third screen. Yes, we'll be showing the other stuff as well. Currently have 3 versions of this thing. A couple are synthetic, so we're doing synthetic data. So we're doing real-time signal amplification, microphone, using a camera. Yeah, I think we made a rookie mistake. We made the very basic mistake where what's actually being measured is that flashing light on the screen. And we can test it easily by covering that. I still want to see. Like a piece of paper or something. Cover it with a tablet. No, the tablet is not big enough. Wait. It's gonna be fun. It's not anything big enough to cover the thing, but essentially what's happening is that it's the light. I don't want to remove the screen, so essentially if I do is what being measured is what's showing that 35 BPM is not real. So we'll cover it by that and see the change. So now it's not flashing light on my face. Okay, now it's doing the real ECG. Yeah, and the frequency have changed. Yeah, 62 is more like it. So it's the light reflecting off the screen. That's what happens when you like monitor the system. Yeah, okay. We'll need to change that. We will need to change that. Okay, so what we currently have, this one's published. I published the other stuff. So there will be essentially 2 versions with synthetic data. And then there will be one that can actually activate your camera and do real-time processing on your camera. Amplify the signal. Process at whatever frames per second. You can set your filters and it will extract the beats per minute, which is your heart rate. But first we'll do it step by step. And we'll have an LLM explaining it properly as well. So put this one in demo mode. I'll have to deploy, while it's explaining it, I'll deploy the other 2 tools. So there's the human in the loop. If you have any questions, go for the chat. go for the chat. So this one is available. Everything we do is available eventually on BioniChaos.com. Go check it out, all the other tools we have made. So cover this one quickly. Okay, we essentially gave this page to a Google AI Studio Gemini 2.5 Pro. I'll just listen to a 5 minutes review.
So what do you think? Pretty cool, right?
It's a beige square that blushes on command. I've seen more excitement on a piece of toast. What am I looking at? The world's most anxious screensaver?
Not quite. You're looking at a simulation of your skin. That blushing is its heartbeat. We're amplifying the microscopic color changes that happen every time blood pulses through the capillaries just under the surface.
You've built a digital vampire that can see blood. Okay, I'm listening. So this magnified video mode is just turning up the volume on the skin's color.
Exactly. It's based on a technique called Eulerian video magnification. We're not inventing the signal, just making the invisible visible. Now, click on Amplitude Map.
Whoa, monochrome. It looks like a sonogram of a ghost. The bright parts are, what, the good parts?
The bright parts are where the pulse signal is strongest. Think of it as a map showing where the major blood highways are. Darker areas have less flow near the surface.
So it's a stud finder for veins. Got it. What about this phase map? It looks like a psychedelic tie-dye experiment gone beautifully right.
This is the clever bit. The phase map visualizes the timing of the pulse. See how the colors change from the center outwards? That's the pulse wave traveling across the patch of skin. Every color represents a different moment in the heartbeat cycle.
Ah, I get it. It's like the wave at a baseball game. The people in the middle start and it ripples outwards. You're tracking the blood wave. So the blue guys are just starting to stand up and the red guys are already sitting down.
That is a perfect analogy. And because we know the timing difference, the phase shift between all these adjacent points, we can calculate the final step. Click velocity field.
Arrows. It's ways for my arteries. It's literally showing the direction the blood is going.
Yup. By calculating the gradient of the phase map, basically looking at how fast the wave is moving between 2 points and in what direction, we can generate a 2D vector field of the blood flow.
So you went from a beige square to a ghost map to a Grateful Dead t-shirt and landed on a traffic report for my circulatory system. That's a heck of a journey. What's this artifacts button do? Make it look like a blurry UFO video?
Pretty much. Real-world video is noisy. You get motion, weird lighting, compression. This simulates that. See the halo effect on the amplitude map? And look how the phase map gets all noisy and chaotic.
It looks like my tie-dye shirt went through the blender. But wait, the velocity arrow is still mostly okay. A bit twitchy, but they know where they're going.
Because the code is smart. The velocity calculation includes a step to filter out the noise. It looks at the phase variance in a local neighborhood. If an area is too chaotic, like that staticky mess on the edges, it assumes it's an artifact and ignores it.
A nosy neighbor algorithm. Hey, is everyone else on this block pulsing in a nice, orderly wave? Yes? Okay, then you, Mr. Disco Strobe Light Pixel, you're clearly drunk. We're ignoring you.
That's a surprisingly accurate summary of local spatial filtering, yes. It's all running in the browser with JavaScript. The generate synthetic data function creates this perfect little blood wave model, and request animation keeps the pulse smooth.
So this isn't just a fun toy. What's the endgame? A lie detector app that checks if your date's heart is actually racing?
The end game is telehealth. Imagine a doctor being able to assess a patient's cardiovascular health just from a video call, or monitoring premature babies in an incubator without sticking wires to their delicate skin. It's about turning any camera into a powerful medical sensor.
Wow, okay, that's genuinely amazing. You're turning a selfie into a medical checkup. And here I was just thinking it'd be a great way to prove to my trainer that I am in fact dying on the treadmill.
Well, it could do that too. Want to try turning on the sound?
You made it make noise? Please tell me it's not a tiny synthesized screaming sound.
It's a heartbeat.
Okay, that's much better. So basically, you've built a beautiful, interactive, data-driven Tamagotchi of a human artery. I love it. Don't tell it I called it beige. I think I hurt its feelings.
Okay, so we have this demo of this synthetic data simulation. We have another simulator, but first, yeah, we're trying to improve a few things. Obviously, the amplitude map and the phase map. The noise was working, but the heart rate actually not changing anything. I don't know if it. This code was generated by Gemini, and let's see if it actually picked up on that. I don't think so. So we'll do an overview of 4 minutes. Notebook LM. It's meant to be about the code itself, and then we will move on to the second simulation.
Okay, so you've seen the code, you've seen the chat about it. What's your first unfiltered thought?
My first thought is that you've created a mood ring for a patch of skin that doesn't exist.
I suppose that's technically accurate. It's a synthetic skin patch, and we are analyzing its mood, if its mood is its blood pressure.
See, you get it. You data scientists call it visualizing hemodynamic signals. I call it making a ghost blush. You're basically turning the volume up on a whisper until you can hear what brand of coffee it had this morning.
That's the essence of Eulerian video magnification. You find a signal that's too small to see, the tiny reddening of skin with each heartbeat, and you amplify it until it's obvious. The magnified video mode is exactly that, turning up the volume on the skin's shy ghost.
Right, and the amplitude map, that's just a map of where the ghost is shouting versus where it's muttering.
Precisely. It shows the strength of the pulse. Brighter areas mean more blood, a stronger signal. It's how you'd find the major arteries.
So, a treasure map for Dracula. Got it. But the phase map, Misha, that thing looks like a psychedelic poster from the 70s. What am I looking at?
That's the coolest part. The phase map isn't about how strong the pulse is, but when it arrives. The color represents the timing. As the pulse wave travels outwards from the center, the color changes, showing the delay. It's like watching ripples in a pond, but the ripples are your heartbeat.
Okay, so if my skin were a rock band, the phase map is the light show that's perfectly synced to the drum solo of my heart. I can respect that, which brings us to the velocity field, the little arrows.
The grand finale. By looking at how the phase, the timing, changes between two adjacent points, we can calculate the direction and speed of the wave. That's the gradient. We're literally calculating the flow of the ripples.
So it's a bunch of tiny caffeinated ants all pointing in the direction the blood is going. And my big question, the artifacts button. Why would you build something beautiful and then add an uglify button?
Because the real world is ugly. It's noisy. People move, the lighting changes. The artifacts button is our honesty button. It simulates the noise and halo effects that real analysis has to deal with. It shows that our velocity calculation is smart enough to ignore a lot of that garbage.
So it's not an uglify button, it's a keep it real button. The code is admitting its own struggles. I like that. It's vulnerable. And the play demo button.
That's just a guided tour. It cycles through the modes and settings automatically.
No. That's the app giving its own TED Talk. First, let me show you my raw, magnified self. Now for your consideration, my amplitude. But wait until you see my phase. It's very confident, your little app.
It has reason to be. And think about the improvements we discussed. Getting it to work on a real face with a webcam.
Whoa, slow down. You want to point my laptop camera at me and have it tell me my blood is flowing chaotically with a chance of anxiety. My boss will start using it in meetings. Yozik, your velocity field looks a little sluggish today. Need another coffee? It's a privacy nightmare and a comedy goldmine.
But the potential for non-invasive medical diagnostics. Checking a baby's heart rate without touching them, assessing burn victims.
I know. You're trying to save the world with math. I'm just here to point out that you've also invented the world's most over-engineered lie detector.
It's all just data. We're just trying to translate what the body is already telling us.
And that's what's hilarious. We spend all this time trying to understand ourselves, our emotions, our purpose, and it turns out we're all just a bunch of beautifully complex, pulsing blobs, walking, talking phase maps. And you, my friend, are the cartographer.
Okay, so there's that. I don't think we will be improving it much further. Obviously, some of the things don't work. The magnified whatever video simulation works okay. So you kind of get the picture of what it meant to be doing. Okay, now we have another simulation. This one is deployed. Our simulation isn't yet. We will deploy that, and we are generating a chat about it. We'll just give the code to Gemini. Starting to give us 2 responses instead of 1. It's a bit unusual. And while it's generating, we'll actually deploy the thing. I think the previous voices were actually better. Not sure. And let's try that. Okay, we have a Python code checking all the pages. Okay, so we have the face blood simulation. We have a face blood sim. So this is now deployed. This is essentially telling you how the principle of calculating the actual beats per minute from the pulsation of a specific color or all the colors, all the RGBs, and extracting the frequency, assuming of course that that's the main pulsation thing is the phase on the video footage. It only works in that case. Yeah, so this one is deployed as well. I can go check it out as well. We'll explain it. Yes, you can change your heart rate, signal amplitude, noise. There's an explanation at the bottom of the page, as per usual. Play the demo. The demo will just scroll all the controllers on the page to show what are they doing. Just good for testing. It's just jumping between them and changing multiple controllers at a time, which is not ideal. Well, better than no demo at all. Better than no demo at all. And we'll have an overview by Notebook LM of the code, and then we move on to the actual thing that actually uses your camera.
So, what do you think? It's my little weekend project.
I think the top graph is what my anxiety's stock portfolio looks like, and the bottom one is my interest in actually checking my portfolio. One spiky, chaotic mess and one lonely, optimistic little hell.
That's surprisingly accurate. The top graph is chaos. It's a simulated signal, like the tiny color changes on a person's skin as blood flows through it, but buried under a mountain of noise. Camera shake, lighting flicker, you name it.
You're telling me you can see my blood moving from a video? Are you a wizard or a very sophisticated vampire?
Neither. Just a data scientist. We're trying to find the pulse, the steady, repeating heartbeat inside that chaotic mess. The top graph is the time domain. It's what the signal looks like moment to moment. It's useless, right? You can't see a heartbeat in that jagged mess.
It looks like a seismograph during a toddler's birthday party. So, what's the lonely mountain on the bottom? Is that like the one sensible thought I have all day?
Exactly. That's the frequency domain. We use a mathematical tool called a Fourier transform, which is a fancy way of saying we take all that noise from the top graph and sort it by its rhythm.
You sort chaos by rhythm? My friend, you haven't seen me dance.
Think of it like this. The top graph is a crowded bar. You hear 100 conversations, the clinking of glasses, the awful background music. You can't pick out any single thing. The Fourier transform is like a magical sound engineer who hands you a mixer. Each slider on the mixer is a different pitch. You slide up the one for a low, steady hum, and suddenly, clear as day, you hear the refrigerator buzzing.
So that big green peak is the refrigerator buzz? The heartbeat?
Precisely. It's the fundamental frequency. It screams, hey, amidst all this random shaking and flickering, there is one thing happening over and over again at exactly 72 beats per minute. Now, watch. Slide the heart rate slider.
Whoa, the lonely mountain is moving. It's migrating. So I can basically give this simulation a panic attack just by dragging this slider to the right?
You are now in control of its simulated autonomic nervous system, yes.
The power is intoxicating. Okay, what's noise level? Is that the my cat just knocked over a lamp during the video call slider?
That is exactly what it is. Crank it up. See how the top graph becomes an absolute disaster? It's pure static. But look at the bottom graph.
Hey, the little green mountain is still there. It's a bit shorter, maybe a little shy, but it's holding on. It's the little peak that could.
That's the whole point. This is the magic. No matter how messy the raw signal gets, the frequency analysis can still find the rhythm, the music hidden in the noise. This is how we can measure a baby's heart rate in an incubator without ever touching them.
Okay, hold on. You're telling me this isn't just a toy for simulating my financial anxiety? You can use a webcam to make sure a tiny human is okay?
That's the real world application, non contact physiological monitoring. And it gets better. You see in the code the simulate FFT function?
You say see in the code like I didn't just spend 5 minutes trying to figure out how to unmute myself on our last call? Assume I'm a golden retriever who's happy to be included.
Fair enough. Right now, I'm cheating a little. I'm telling the bottom graph where the peak should be based on the slider. It's a magic trick. The next step is to use a real Fourier transform algorithm and let it discover the peak on its own from the noisy data I'm generating.
So right now you're the Penn and Teller of signal processing. You're forcing the card, so to speak.
I am. It's a teaching tool, but once it's real, we could add a band pass filter.
Sounds like something my car needs.
Almost. It would let you draw a box around the green peak on the bottom graph, and it would tell the top graph, hey, ignore all the other noise. Only show me the signal that corresponds to this rhythm. And the messy top graph would suddenly turn into a clean, beautiful sine wave.
So it's like noise canceling headphones for data? You just tell it to ignore everything except the sweet, sweet sound of blood pumping? That is ridiculously cool.
Right?
So, to summarize, you've built a web page that can look at a video of my jittery, coffee-fueled face and tell me with the cold, hard certainty of mathematics just how close I am to vibrating into another dimension.
I'd prefer to think of it as finding the music in the noise.
Potato, potato. Now, if you'll excuse me, I'm going to turn on the sonification and give this thing a heart rate of 120 beats per minute. It's time for its morning cardio.
To do what the robot says. So sonification on 120 BPM. Yes, you can see if we increase the noise, motion artifact, reduce the signal at a certain signal level, it can barely find that peak in the frequency domain. So that that noise is annoying. The other one had a better sonification to it. That sounds more like a heartbeat. And we have the real version of it. So those two are synthetic. One is mimicking a face on the screen, and how we measure blood pressure, blood circulation out of it. The other one is how we actually calculate the beats per minute out of that pulsation, out of that color differentiation. And now we have the real thing. Now we have the real thing. Okay, so we have the real thing. You can go try it out yourself as well. I'll talk about this some more. So this is deployed on the website as well. Everything we do is on BioniChaos.com. So this one here. Wait. So you need to, in this particular case, you need to select the ROI, the region of interest, for it to work. Now we had good quality. Problem is, there's a don't make a rookie mistake. If you have something like this flashing on a screen, it's more likely that's what it's picking up. Is if we block it by something. If we block it by, we can block it by an image. Let's block it by that. And see what happens. Now we should actually see the real. So over there, what was happening is that the flashing colors were actually picked up. Well, obviously picked up by the camera. That's what we were seeing that 30 bits per minute for. If I stop moving. I think that's my real BPM. The quality is poor. Why? We have light. And have more light. So the region of interest is that. Oops, it's not connected. Wait a sec. Was not connected. What's this standing in here? We have a smaller RPM. Well, so those amplifications are wrong. It's because of the flashing light. This is the real thing. And now we should see a peak. Yeah. Around 2 Hertz, which indicates 70 BPM, which is my bits per minute. Yeah, the signal is noisy. It's still over my forehead. We can automate the phase detection. Yeah, so you can see it. Then turn off those flashing. The flashing light's meant to amplify the thing. If we have more light, yeah, light could be problematic because if I'm using this LED light, it could actually distort stuff. It could actually distort stuff. Yeah, there it is. If I don't move and don't talk and don't laugh, you can actually recover pulse rate, blood pressure. Not blood pressure because it doesn't have systolic, but you know what I mean, the heart rate. So the beats per minute. So it's working fine. But yeah, not to be confused with this stuff, which is not the correct thing. This is the flashing stuff, which we need to get rid of. Yeah, so we went through this simulation of the theory behind it, of simulated patch of the skin and how blood is circulating in your face. This is obviously just the simulation, will be faster or slower. Pretty much all that does. Then we have the theory about how to actually calculate. Well, I mean, there's no equations. We don't like equations, but it's just how we calculate. I actually can bring the thing. I'll put it on a separate screen, see if we can monitor it continuously. Anyhow, so we have the theory behind how the signal, so those are fluctuations in the color extracted from the video footage. And then we converting it into frequency domain. To extract the bits per minute. This is all assuming that the main color change is to do with your face being on the screen in the video footage. Where's the real time? Yeah, that one. We can show it on the screen somewhere. So this is the actual. So couple things with that thing is that first of all we need to again get rid of that. So first of all, you can go try it out yourself and see how it works in your lighting conditions and everything. It might work better or worse. That's probably the main reason why it's not using in clinical practice, is calibrating this thing will be a pain. Be quite a pain. Will be quite a pain. Yeah, that thing flashing, well, now it's just a tiny thing. It's gonna recover good signal. Maybe. Anyway, you saw before you can, by not moving, having better light. You can try it again in a sec. Question is, do we need anything improved with this thing? Yeah, the flashy business. Okay, so let's. So it's extracting RGB as well. Extracting RGB. Start a new chat. So Gemini is pretty good. Gemini meant all the code for us. Thank you very much. There will be actually future directions in there as well, indicating what can be done. So run a local version. We will run a local version. Yeah, you need proper lighting. Check the signal quality. Should be stable. Yeah, so this thing in the FFT should have a nice clear peak. What else? Yeah, have to stay still because it's actually extracting minor changes and amplifying them as well. Changes in color in the video footage within the ROI. Which we can adjust. We should be able to adjust manually. Sorry, so we are able to adjust it manually. We should be able to add a functionality that will make it possible to adjust it automatically, to just find your face. Ideally, we'll find all the skin within the face. I haven't seen that one done before. There's some kind of making a lot of assumptions of where the skin is. Yeah, future direction, automated ROI selection, face detection library. Yeah, media pipe will do. Could be integrated to automatically detect the user's forehead. Wonder if it can, if there's anything that could find the skin. Any skin. Any skin would be good. Motion compensation, advanced techniques like optical flow tracking could be used to stabilize the ROI on the face, making the system far more robust against small head movements, which are currently the primary source of noise. That's correct. Yeah, web worker integration is, we're not gonna do that. But I'm mainly wondering with the amplification. Let's talk to this thing. Yeah, because currently it's causing trouble. Okay, so with the amplification seem to be currently being too high, but also when the amplified video feed is flashing, what the idea was that we will amplify that blood flow within the area of interest, within the ROI, within the region of interest. But what's currently happening is the whole canvas, the video feed is flashing with different colors. I think, yeah, it's not working very well. It's not working very well. Let's see if a Gemini 2.5 Pro has any suggestions on that. Obviously the cutoff should be what it is, but if just for considering having so much noise, if we make it say 40 to 55, yeah, then it's flashing like crazy. There was some, yeah, this what meant to happen. It's essentially picking up, it's essentially too sensitive. It's picking up on, let's reset it for a sec. Yeah, your frames per second will define the frequency domain there. So if you have 40 Nyquist rate, will be half of that. Taking into account we default use 30. We can go all the way up to 60. It's not actually 60, it's like 59 something. Yeah, but 30 should be plenty. I think amplification of what was it, 200? I think it's too much. We need around the 80. We don't need to amplify that much. Currently we don't have automated ROI selection, so we have to do this. And yeah, the problem with that flashing thing is that that color, the green and red, whatever, magenta, is going into the video feed, and that's what's being detected as my BPM, which is obviously wrong. We want to turn it off. Why did it regenerate the code for us? Why? Yeah, we do measure signal quality as well. And we have green, signal quality is good, reading should be stable and accurate. I think it's actually looking on how much FFT peak we have. Yeah, that's a real problem. Don't fall for it. Don't make a rookie mistake. Yeah, whatever you have on the screen. So say if you're watching a YouTube video, whatever, and it has flashing light and then lights, and then you're trying to record your beats per minute heart rate, then it could be wrong because it's essentially just recording the flashes on the screen. So I'm trying to get rid of it. What did it do? The twofold above problems are related to how the amplification effect is being rendered. Yeah, we don't want that rendering of flashy stuff. Make the shader ROI aware. We'll pass the ROI coordinates to the WebGL. Yes, and we are using WebGL. So using the graphic card in the browser. A fragment shader. The shader will then check if the pixel it's currently processing is inside those coordinates. If it is, it applies the amplification. If not, it leaves the pixel alone. This will contain the effect perfectly within the box you draw. Yeah, so I wanted the flashy bit just in the ROI. I think that's what it means. We'll have another copy and to index. Kind of don't have a proper version control. So I'll do index 1. We have the code, updated code. Let's see what it does. Can run it in. Okay, so now we have that amplification. Shrink quality is good. We want to see. Wait. Let's do more light. Some nonsense. Should see a peak over here. Yeah, that peak is the actual BPM. Everything else is rubbish. Yeah, and 70 probably sounds like right. 77, it's a bit elevated. Quality good. Now I'm convinced that's the actual heart rate. Okay, this version is better. Yeah, when you start moving around, obviously, yeah, it's losing the plot. Turn off. That light is in my face. I don't know how other YouTubers have like all these lights in their face. Okay, let's actually get rid of the previous version. This one is definitely better because it's not flashing all that stuff. It's not flashing all that stuff. Again, I've been talking for too long again, and if there's any questions in the chat, go for the chat. Happy to talk to a human. Where's that code? So next thing we'll be doing automated face detection, which we had a version of. Yeah, MediaPipe will do. There's also another thing that we could use, but essentially it should find the skin on the face. How hard would that be? How hard would that be? But you saw the measurement before. Yeah, if you don't move, get certain lights, good light, then can do the measurement. Okay, so with MediaPipe or any other tool, I don't care which tool we use to actually trace the face, any chance we can actually mark all the visible skin in the footage, in the video footage, do it live, fast. We do use WebGL at the moment, don't we? So that so speed should not be a problem. Also we need to then look at the amplification factor. I think it's too high at the moment. Currently it's going all the way from a 0 to 400. Yes, certain number will actually supposedly indicate the blood rushing. We keep it 56, make it small. The quality. Should see. Yeah, within this range of between 1 and 3 hertz, we should see a peak. Well, it's not there. I don't know what's up with the amplification. There's a peak there. Let's do more light. Yeah, I want this to stabilize, so I'll just stop talking. I can't get it. Is it because the ROI is too small or something? Yeah, I'm pretty sure that's my BPM. Yeah, having a really nice peak there. Yeah, so the ROI size makes a difference. Can we get it with no extra light? So interesting enough, it can be used to detect AI generated people. No, it's harder with no light. I'm not sure about the amplification factor. And what did we ask? I will integrate Google's Media Pipe face mesh. Integrate face mesh. Will it work? Well, that's one way to find out. Is just hey, test the code. I'm not gonna read the code. Sometimes when you copy to clipboard, it doesn't even copy the entire code. So this is like the whatever 20 version, but a third. It's the formal number. And how is it a much shorter? Yeah, this is where. Did it just do the media pipe stuff? Does it need like a URL access? No. Hey, can we make sure all the previous functionality is there? So don't remove any current functionality. Okay, I have to do it again. Yeah, we don't like this one. This one will go. Anyway, we have the theory behind it. This is a synthetic patch of the skin. This is how we actually calculate the beats per minute out of the color fluctuation on the face. And this is the actual thing up and running. And you saw before. If we have a large enough ROI, if we have good light, and I don't move, we get a good quality heart rate. Very nice. And what on earth Gemini is doing? I think it's hallucinating on me. Anyway, I will just give it to the bot to review the code. Which one? Yeah, this one is a good. This one meant to. Highlighting all skin. No, it's highlighting me. It's highlighting the skin. Highlight all skin. Okay. But then it's not actually. That's not skin, is it? Recognize clothing? No. It's still doing it from. So it's highlighting me, which is nice. It's not the skin. It's not recognizing clothing. It's assuming I'm naked. And then it's not actually using it. Is it? No, it's still using the ROI. It is still using the ROI, which is a bit weird. So it's not clear at the moment. Is it using the square, the manual ROI, region of interest, that I mark for the detection, or is it using the skin detector? I think it's using the ROI box. Can you confirm what's going on? We might need more options there. It's kind of okay. It's not. Yeah, ideally it will deselect, the jumper, just find the face. Could just assume and ignore the hair and the beard, but not sure if it can do it. It's happening now. Pulse calculation, the heart rate is calculated exclusively from the pixel inside the manual green ROI box. The solution unifying the visuals. To eliminate this confusion, we'll change the logic that green skin highlight is also confined to the ROI box. What? To create a clear, intuitive, the box you draw analysis area inside that box. Oh, right. So you will draw like a box like this, and inside it will find the. Is that what's doing at the moment? No. But it generated complete code. What is it? What? What? It doesn't seem right. First we'll get rid of some of the code from before. Hey, can we leave all the current functionality and have an option for either selecting manual ROI or have automated the ROI selection, which will try and find all your skin, but will ignore clothing, hair, beard. So we'll just essentially find the forehead and areas under the eyes and nose. Is that possible? Misspelled nose. Mispronouncing Eva, whatever. Hey, can we also make sure all the current functionality is still there, so don't remove anything? We expect the code to be longer. I don't know why I need to mention that, but we have to try. The previous version was manual ROI selection, and we saw it did work. Yeah, let's give the code. Let's give the code to another bot. We will generate a standalone deal, yet a conversation between a data scientist and a comedian. Code. About this project, the code, what we're trying to do. Yeah, that sounds good because I've been talking for too long and there's no human on the other end. If you do have questions, pop them in the chat. Happy to take any questions. Otherwise, everything we do is available on BioniChaos.com. Go check out the website and again, provide your feedback. So we have Gemini 2.5 Pro generating our version of the code. All we're trying to do is have this version have both a manual region of interest and automated one. So in this case, it's actually trying real hard to find the skin. How much will we use? It's only 83 megabytes in the browser, so it should work pretty much anywhere. It's doing an okay job. Maybe, maybe not. We have a script. We have a script. I don't know why. It seems much shorter. Highlight all skin, enable signification in manual ROI, automated ROI face. Okay, so finding the face. We're finding the face. Highlight all skin. Okay, so what is it doing? Is it working? We will generate conversation, notebook LM. Skin, skin, skin. That's only doing the face, no hands. So if I don't move, quality is poor. Do we need more light? We'll close that. Not sure light helps. We'll keep testing this. Keep testing this. Copy as text. We have a conversation. I think it will just start talking when it's ready. But no, I'm not getting. I'm not getting it. Wait, where's the manual? So when we have the well, first we have to check it as we did before. Okay, it is there. So it's working. Now what happens? What? Yeah, the automated. This light is killing me. The automated. So can we just confirm when we have the automated ROI phase, we have the highlight all skin. Is all the highlighted skin is taken because it's highlighting hair and jumper, clothing and everything. It's not just highlighting the skin. Is that that could be an issue, isn't it? Can you explain how the automated ROI actually works? What happens if we don't just have a skin as a region of interest? It might be a problem, doesn't it? Okay, the play demo is actually faking it. It's pausing the video footage, showing quality good. Yeah, changing the amplification factor and stuff. So yeah, that's just fake, which is really good for streams because I can go have my lunch or something.
So, what do you think? My forehead is practically strobing to the beat of my own heart.
I think you've finally done it. You've invented a way to tell if someone is lying just by looking at their face disco. My forehead is currently flashing like a faulty neon sign that says mildly anxious.
It's not anxiety, it's just hemodynamics. We're running a real-time Eulerian video magnification pipeline. We take the video feed, isolate a signal, and amplify it back onto the image.
You say hemodynamics, I say living mood ring. You know the code is working when your face turns the color of guacamole every 0.8 seconds. So break it down for me. Why green? Do you have a thing against the other primary colors?
It's because hemoglobin, the protein in your blood that carries oxygen, absorbs green light. So when your heart pumps blood into your face, the capillaries flush, absorb more green light, and reflect less of it. The camera sees a tiny dip in the green channel. We just grab that dip and turn it into a tidal wave.
So my face is a radio station, and you're not listening to the music, you're listening to the silence between the songs, and you've turned the volume on the silence up to 11.
That's a surprisingly accurate analogy. The raw signal is incredibly noisy. That's where the code gets fun. First, we detrend it to remove slow changes, like if the sun comes out from behind a cloud.
Detrending? Is that what happens when you finally stop wearing skinny jeans?
Something like that. Then we run it through a digital bandpass filter. We tell it we only care about frequencies between, say, 0.7 and 3 hertz. That's the typical range for a human heart rate, from 42 to 180 beats per minute. Everything else, camera noise, flicker from lights, your head moving, gets thrown out.
It's a bouncer for data. Sorry, Mr. Jittery Head Movement, you're not on the list tonight. Only you, Mr. Rhythmic Pulse, can come in.
Precisely. After that, we apply a fast Fourier transform.
Oh, here we go. You've summoned the incantation. Does a math ghost appear when you say that?
It basically turns the squiggly line of the pulse over time into a bar chart of its component frequencies. The tallest bar is the dominant frequency, your heart rate. We just find that peak, do a little math, and bam, beats per minute.
And what's this signal quality thing? Is that the computer judging my life choices? Mine currently says fair, which is what my teachers used to say about my attitude.
It's measuring how peaky that peak is. Is it a sharp, undeniable Matterhorn or just a gentle hill in a range of other noisy hills? Excellent means the signal is crystal clear. Poor means you're probably moving too much and the signal is garbage.
So when it says poor, it's politely telling me to stop having emotions and to become a statue. Understood. Now, about this box. At first, I had to draw a little green prison on my own forehead. Stay in the box, Pulse. Don't you wander.
That was the manual ROI mode. It works, but it's clumsy. If you move your head, you leave your ROI behind. The real magic is the new automated mode.
Ah, yes, the yellow dots. My face is now being gently acupunctured by a benevolent AI. It's slightly more dystopian, but definitely less effort. How does it know where to put the pins?
That's MediaPipe Face Mesh. It finds 468 landmarks on the face in real time. We picked a handful of them on the forehead, the cheeks, places with good blood flow that usually aren't covered by beards or glasses. The code then averages the signal from all those points. It's much more robust against small movements.
So it's crowdsourcing my own pulse from different parts of my face? My forehead and my cheeks are having a little committee meeting to decide how fast my heart is beating.
Exactly. And notice the intense amplification effect is only visible inside the manual box. We didn't want the auto mode to make your whole face throb. That would be unsettling.
Your word is unsettling. Mine is hilarious. So what's the grand plan? Are you going to sell this to teenagers so they can see their pulse spike when their crush walks by?
Telehealth primarily. Imagine a doctor getting a patient's heart rate from a simple video call, or monitoring a baby in a NICU without attaching wires. We could even point it at structures, a bridge, a building wing, and amplify its tiny, tiny vibrations to see if it's structurally sound.
You're going to point this at a bridge and see if it's having a panic attack? That's brilliant. Doc, the Golden Gate is looking a bit stressed. Its BPM is way up.
It's all just data hidden in plain sight. We're just building the glasses to see it.
Well, my glasses say my signal quality has just dropped to poor. I think that's the code's way of saying it's tired of hearing me talk.
Okay, there's a human in the loop. We can stop this demo. The demo is quite good. Yeah, there's quite a few problems with the tool itself, which we have a very experienced developer trying to fix. A Gemini 2.5 Pro. Did we actually use yes, we did. Yeah, so we know the manual ROI is working. We can actually extract the heart rate. Not sure if the automated ROI is working correctly. Currently it's extracting skin. It's not doing very good job. Yeah, doing FFT, all that seemed to work. Real time. Yeah, the face mesh. Yeah, that's not correct. The sonification should be also happening just within the manual box. It's still working correctly. Might need the ROI a bit larger. Yeah, well, anyway, it's definitely there. Yeah, we need some more work on the automated ROI selection, and specifically for it to choose the skin. Okay, if there's no questions, we will finish up. We'll finish. We will call it a day. Everything new is available on BioniChaos.com. Go check out the website. Provide your feedback.